Hello everyone, welcome to Chemizon Complete Chemistry. So in our today's video, we are going to learn a very important concept of stereochemistry, that is chirality. So what do we mean by chirality? So chirality is the geometric property of any rigid substance by virtue of which it is asymmetric. So when we extend this concept in chemistry, where a molecule, any asymmetric molecule, we call that molecule as chiral, and this phenomena is called as chirality. So let us first understand this concept of chirality by common objects that we see in our day-to-day life and in some examples, and then we will extend this concept to chemistry. So in this slide you can see that there are two molecules, that is this molecule on the left and this on the right. Both are enantiomers of each other, means they are actually the same molecule, but only the stereo descriptor is different. That is, this first one is a Darwin, as you can see. This molecule is a painkiller, whereas this second molecule, which is called as Novrad, which is an anti-cough agent. So now we have to realize that how important this concept of chirality is, that in the same molecule only the stereo descriptor or the enantiomer is different, and the properties accordingly change completely. That is, one is a painkiller whereas another is a anti-cough agent. Here is another beautiful example of chirality in nature. That is, the first structure that you can see is dextrolimonene, that is plus limonene. This is an enantiomer which is found in oranges, whereas if we see the levoisomer of this, then this is the enantiomer found in lemons. So here you can see another object, that is this glass, and you can see its mirror image. And if we see these, if we try to superimpose this mirror image on this original object, we will see that it is completely superposable. This concept of superposable and non-superposable we have already seen in diastereomers and enantiomers. It was a very important concept. So here you can see, we all know that the mirror image of right hand is the left hand, and both the hands are not superimposable on each other. Whenever any object is superimposable on itself, we call that particular object or molecule as chiral. Like we saw the picture of glass in the last slide, that was a chiral. Here you can see this mug. Again, this is chiral molecule because its mirror image will not be superimposable on this image. This is another beautiful example of helical chirality. That is, this is a photo of a plant which shows a helical type of structure or chirality as we see in a DNA molecule. So this is let us understand in a much better manner by this example. Here you can see this is a amino acid molecule where there is a carboxylic acid group and there is a amino group, amino and acid, that's why it is called as amino acid group. So these are two different enantiomers of amino acid. So let us illustrate with the help of an example. Suppose this is any substrate, and this amino acid has to act on this substrate. So you can see that this molecule will be able to act on the substrate or bind to the substrate, but its enantiomer will not be able to bind, although they are same molecules. Just the difference is that they are enantiomers of each other, that is, they are non-superimposable mirror images. So let us now understand the concept of chirality in organic chemistry. So here you can see there is this tetrahedral carbon which is attached to 4 different groups, and if you see its mirror image and if you try to superimpose one another, then it would not be possible. So this molecule is called as a chiral molecule. Similarly, we have also seen some molecules which do not have a chiral center or a chiral carbon, but still some molecules which are chiral or show chirality, they are like this biphenyls. We had already seen there is no chiral carbon as such in this molecule, but overall this molecule, that is this biphenyl molecule, is chiral under certain chirality conditions. Another molecule we had already seen is this allene or cumulenes type of molecule, and also this type of molecule, this is called as a spiro compound, where the two rings are attached at a single point of attachment. These type of molecules, that is the spiro compound, also show chirality. This is very similar to allene molecule that we had seen. Just the difference is that instead of double bonds, it is this cyclobutane rings. So this is a reference book that I used. So this is the end of today's video. Thank you so much. In the coming videos we will learn more about elements of symmetry. Like a molecule to be asymmetric, the elements of symmetry should be absent in that molecule. So this concept we will be learning in the further videos. Thank you so much.